Well, hello, Algebra. Today we're going to be doing 2.0b, which is just talking about slope and rate of change. That's slope from 2 points, slope from a graph, and slope from a table. So if we're going to find the slope, also known as rate of change and slope is the same thing. So sometimes we use slope, most of the times rather we use slope, but it is the same as rate of change. The slope is the ratio of the change along the y-axis to the change along the x-axis between 2 points, any 2 points. Once you have identified those 2 points, your slope is the change in the y2 minus y1, over your change in the x, which is, I forget to change this every year, x, make it a color, x2 minus x1. So your slope is y2 minus y1 divided by x2 minus x1. And that's because when we first find our coordinates, we're going to label them. The first point, doesn't matter which one you call the first point, but the first point you're just going to call x1, y1, because every point has an x and a y. The x is first, the y is second. But this is your first point, we call it x1, y1. The second point, because it's the second point, we're just going to call it x2, y2, because it's the second point. To find the slope, how it changes, your slope is y2 minus y1, your change in y's, divided by x2 minus x1, or your change in x's. From here, we're just going to substitute it. So y2 is negative 2 minus y1, which is 3, and it's divided by x2, which is negative 1, minus, from the formula, x1, which is 3. Let me give you some colors just to kind of help you out. Uh-oh. So y2 minus y1. This thing is not working for me. Let me put it in the pen, different color. Y1 and it's being divided by x2 minus x1. I just wanted you to see where I'm getting those numbers from. Y2, y1, x2, and x1. Now, once we do that, we're going to solve like we would any other old day. So that m, your slope is equal to negative 2 minus 3, which is negative 5, divided by negative 1 minus 3, which is negative 4. Therefore, your slope is equal to positive 5 over 4, because the negative divided by a negative is a positive. Let's look at number 2. For number 2, again, we are trying to find the slope. Your slope is equal to y2 minus y1 over x2 minus x1. So your slope is equal to y2, this is x2, x1, and y1. So your slope is equal to negative 8 minus y1, which in this case is negative 3, and it's going to be divided by x2, which is 3, and minus x1, which is -4. So that your slope is equal to -8 minus -3. A negative and a negative makes a positive. So that's really -8 plus 3 divided by 3 plus 4. So that your slope is equal to -5/7. So -5/7. I'm going to do two more with you. All right, so again, my slope, we're just looking over here. I have 2 points. I'm going to first start off by labeling my x1, y1, x and y for the first point, x2, y2, and then I'm just going to substitute it into my formula for slope. Slope again is equal to y2 minus y1 divided by x2 minus x1. So let's look for y2. Your m is equal to -1, that's y2, minus y1, which is +5, divided by x2, which is -2, minus x1, which is 5. So that your slope is equal to -6 over -7. So that your slope is just equal to +6/7. +6/7. All right, now let's look at number 2. I'm going to do this one again with you. Then I want you to try some on your own. Go ahead and label it x1, y1. Then label it x2, y2. And now we're just going to substitute it into the formula. Your slope is equal to y2 minus y1 divided by x2 minus x1. And that formula is not on your reference sheet. You do have to know it, and know what it is. All right, so that my slope is equal to y2, which is 6, minus sine y1, which is 4, divided by x2, which is 6, minus x1 that I labeled, which is 3. So that the m is equal to 6 minus 4, 2, and 6 minus 3, which is 3. M is equal to 2/3. That is your slope. Your slope is 2/3. Now I want you to pause, and you are going to try negative numbers, the zero slope, and the undefined slope on your own. Go ahead and try. That's going to be a comment. All right, now that you have tried and you are back, you should have gotten for the negative area, the next two, negative slope, m is -2 and m is -6/5. This is a negative slope. If you notice before that, we had two positive numbers. It's a positive slope. The zero slope, when you finished, m was equal to 0, and 0 divided by a number is just 0. So your slope is a zero slope. And when you came to the last one, if you put that 2 divided by 0 in your calculator, you would have gotten an error, which means you actually can't break it up. You cannot break something into nothing. So those slopes are what we call an undefined slope. It's actually a very unique slope, but the terminology is undefined. It is an undefined slope. All right, so let's look at the positive slope. A positive slope, whichever one, you could tell it's positive because it would be going up. That's a positive slope. That's what it looks like visually. Numerically, that's what it is. And to the left, that's what it looks like visually. If it's a negative slope, it will be going down. That's a negative slope. A zero slope, it is not going anywhere. It is flat. This is a zero slope. For a zero slope, it's y equals a number because it goes through the y-axis. An undefined slope is straight up and down. It's vertical. And because it never touches your y, it's x equals a number. Okay, so now we know how to find slope from 2 points. We're going to keep going, and we're going to learn how to find slope from a graph. Now, from a graph, you could also use the points if you can find out what it is. Let's say you want to use that coordinate and that coordinate. Once you have 2 points, you can use the 2 points, y2 minus y1 divided by x2 minus x1. But you could also count, right? So we said your slope is your rise over how you run, change in y over x. So rise means how you go up or down. Run, you have to run on the ground. So your run is how you go left or right. Now, before you go somewhere, when you wake up in the morning, you have to get up out of your bed before you walk on the floor. As such, when we're finding the slope, we could go up first. So we could go up, let's see, 1, 2 units. That's positive 2 because you went up 2. And then you would go to the left 1 unit, backwards 1. So that your slope would be negative 2 over 1, which is just the same as negative 2. That becomes a little easier when it's on a graph and you could clearly see where they intersect. If I didn't want to go up and left, I could also go down. But if I went down first, that would be negative 2. And then I would go to the right, which is positive 1. So that my slope would be negative 2 over 1, which is the same again as negative 2. So if I go up and left, it's the same as going down and right. Let's look at number 3. You want to look at where you have the perfect intersections. So here's my function. Where does it cross the road perfectly? I don't want to look in here or here, but here are these perfect intersections at these dots, right? So if I want to find the slope, I know I would get from here to there by going up 1, positive 1, and to the right 1, positive 1. And you could also tell, you see how the line is going up? It's going to be a positive slope. So that m is equal to 1 over 1. My slope is just equal to 1. If I was going the other way, I could say that this went down 1, which is negative 1, and then to the left 1, negative 1. So the slope is negative 1 over negative 1, which is the same as positive 1. Negative divided by a negative is a positive. I'm going to do number 5 with you, and then I'm going to let you try number 2, 4, and 6. So here on number 5, again, I see this going up. I could tell it's going to be a positive graph. And then here's my next coordinate point. So to get from here to here, I would have to go up 1 and then to the right 2. So that my slope is 1 over 2. Now you might say, oh, why didn't I just go across the line itself? It's like saying you are going from your house to the store. You can't make a straight line for it. You actually need to follow the roads in your neighborhood and turn in order to get to a light maybe and then get to the store. You can't drive through homes in a straight line just to get from, let's say, your store to school. There you go. You got to go to school. So from your home to school, you can't make one straight line because there are homes in your path, or there's probably a lake in your path. There's water in your path. So you actually have to take the roads that's going to take you to school. You can't travel along the green line, but you could travel along the roads in order to get there. Okay. Go ahead and pause now And then I want you to 2, 4, and 6. All right, now that you are back, you should have had for number 2. From here, you could go up. Oh, here's my point over here. You could go up 2, so that's a positive 2. And to the left, 1, 2, 3, negative 3. So that your slope is 2 over negative 3, which is just negative 2/3. Number 4, you should have a point here and a point here. Maybe you went down 1, negative 1. And then you went to the right, 1, 2, 3, positive 3. So negative 1 over positive 3, that's your slope. Now let's look at number 6. You could have gone down 1 and right 3. Down 1 and right 3. Or you could have gone up 1 and left 3. Which would have been 1 over negative 3. But keep in mind, a positive divided by a negative, it's still just negative 1/3. So your slope is negative 1/3. Oh, that's there as well. All right, now let's come on down. If you want to find the slope from a table, it's going to be the same thing as the 2 points. You just have to make 2 points. Tables are made up of points. So maybe you want to pick this coordinate and that coordinate. It doesn't matter which coordinates you pick as long as you pick 2. Now, remember, if this is your x and y from a table, that means your coordinate is 2, 1. And the next coordinate is 2, 3. Now, let's remember what we just did. In order to find your slope, you're going to label it x1, y1 and x2, y2. And then you are going to solve. So y2, which is 3, minus y1, which is 1, divided by x2, which is 2, minus x1, which is 2. Oh, it's going to give me, what's that, 2 over 0. This is undefined. Go ahead for number 2. Pick 2 points. Pause and try. Pick any 2 points and find the slope. All right, I'm going to pick 0, 1 and 5, 11. So my coordinate is 0, 1 and 5, 11. Doesn't matter which one you picked. x1, y1, x2, y2. So that 11 minus 1 divided by 5 minus 0 is going to be equal to 10 divided by 5, which is 2. So my slope is equal to 2. All right, that's it from slope. So now let's come down and we're just going to identify what some intercepts are, which is a vocabulary term. The y-intercept is just the y-coordinate of the point where it crosses over the y-axis. So here's the y-axis. The y-intercept is right here where it crosses the y-axis. And this coordinate is, what's this? 0, 1. Your x-intercept is where it crosses over the x-axis. So y-intercept, y-axis, x-intercept is where it crosses over the x-axis. So here's the x-axis right here. The x-intercept is 2. So your y-intercept is 1. The coordinate itself is 0, 1. And your, I put that under the x. Sorry. Your y-intercept here is 1. And the actual coordinate is 0, 1. Your x-intercept is negative 2. And the actual coordinate is negative 2, 0. Let's look here. Here's your y-axis. There's your x-axis. Your x-intercept is where you cross the x-axis. Just look for the x-axis. This is it, literally, right there. Your x-intercept is at 4, and the coordinate is going to be 4, 0. Your y-intercept is here at 2, and the coordinate is going to be 0, 2. Go ahead and pause. Try 3 and 4. Right, now that you're back, the x-intercept, oh, where's it crossing the x? Right here. It's at 0. And the coordinate is 0, 0. For the y-intercept, sorry, I didn't put that there, it's also at 0. And the coordinate is 0, 0. Coming on over to the next one, your x-intercept, boom, here it is at -1. And the coordinate is -1, 0. And the y-intercept is here at 2. And the coordinate is 0, 2. Notice that for every y-intercept, your x value was 0. Must be. And for every x-intercept, your y value is 0 because you're actually crossing the x-axis. Now we are about done. I want to just come up here a little bit and talk about domain and range, and then we'll be done. So when I look here for number 1, because these tend to be all the same, there's an arrow on the edge of the line for both of them. So that means your domain, all your x values will be all real numbers. It can also be denoted as, let's see, your domain is every x value such that x is all real numbers, also going from -infinity to +infinity. Your range, because again, it's a line, there are no closed circles, open circles, it's just the arrows. Your range is also going to be the same thing, all real numbers. So your range is every y value such that your y is between -infinity and +infinity, and your alligator chomps to the right. Okay, that is it for this lesson. Hope you learned a lot. Remember, in order to learn your mathematics, be sure to do your mathematics.